What are capacitors? How do they work? What do we need them for? Let's try to give an answer to all of these questions.
Hi there, I am Carlo Carrano and this is Electronics Engineering Made Easy. A capacitor is a device that essentially stores electrostatic energy in the form of charges that are applied on its plates. So a capacitor is made of two metallic plates connected to wires, and in between there is an insulator, which could be air or paper or some sort of plastic or other kind of chemicals, which we call a dielectric. Whenever we connect the wires of the capacitor to a power supply, we force electrons to move away from the plate connected to the positive of the power supply, and we force other electrons to be pushed inside the plate which is connected to the negative side of the power supply, in such a way that we will have an excess of electrons on this side, so that this plate will be polarized negatively, and a defect of electrons on this other side, leaving behind the positive charges of the atoms that are now no more balanced by the electrons that are missing. The number of electrons that are added to this side is the same number of the electrons that are removed from this other side. So there is some sort of equilibrium at this point. Now, if we disconnect suddenly the power supply from the capacitor, the charges that are accumulated on this side and the ones that are in defect on this other side will be forced to stay over there. So there will be no electrons that will be able to go to this plate, and these electrons will not be able to leave this other side of the plate because they will be attracted by the positive side of the other plate. So at this point, we say that the capacitor is charged, and it is charged to a voltage that is basically the same as the power supply that was used to charge it. Now, if we connect the two sides of the capacitor back together without the power supply, now the electrons that are accumulated on this plate, on the right plate, will be free to move around and go back to the position that they left on the other plate, which was charged positively. So basically, there will be a current of electrons flowing this way until there will be a new equilibrium where there will be no charge and no excess of charge anymore on this side and no defect of charge on this side anymore. So basically the situation will become like this. At that point, the current will stop flowing, and we say that the capacitor is discharged. Now, how fast the charge and discharge of the capacitor happens depends on the resistance of the wires that connect the capacitor first to the power supply for the charging, and then we short circuit them for the discharge. The higher the resistance, the lower the amount of current that can flow through the circuit, and so the slower the capacitor will charge or discharge. Now let's go back to the circuit that is used to charge the capacitor. Something like this. And actually let's represent the resistance of the wires that connect the power supply to the capacitor with a component like this. So when we close this circuit, there will be a flow of electrons leaving this plate and moving toward the other plate until the capacitor is charged with a voltage that is the same as the one of the power supply. then everything will stop, the flow of electrons will stop, there will be no more current, and the capacitor is said to be charged. If we apply a different amount of voltage, like for example 2 times the amount of V, the amount of charges that will move into the circuit will double. And if we put it 3 times, then the amount of charges will be 3 times that amount. So what happened is basically that the ratio between the amount of charges on the capacitor and the voltage applied to the capacitor keeps constant. And this is the value that we call capacitance of the capacitor. So it's a constant number which depends uniquely from the physical characteristics of the capacitor itself. We can actually say that the capacity is higher when the plates have a higher surface, a higher area, and the capacity would be smaller if the distance of the plates is greater. And also the capacity depends from the kind of insulator that is in between the plates. If it is air in between the plates, then the capacitance will be a certain value. If there is some other insulator, some other dielectric, which is not air, in general the capacitance will be higher. So at the end we can write a formula that describes the value of the capacitor in terms of these physical constants. So we can say the capacitance of the capacitor is equal to this number, where A is the area of the plates, D is the distance of the plates. You can see the greater the area, the greater the capacitance, like we said. And the greater the distance, the smaller the capacity, like we said. And then there is this value, which is a Greek letter epsilon, which is basically a constant that depends on the kind of insulator, the kind of dielectric that is in between the plates. The value of epsilon is usually determined by the product of 2 constants, epsilon 0 and epsilon r. Epsilon 0 is the dielectric constant of the air if there is nothing in between the plates of the capacitor. Epsilon r, instead, is an adjustment constant that is multiplied to epsilon 0, which depends on the particular kind of substance that is used in between the capacitor when we replace the air with this substance. This value is usually greater than 1, and that's why when there is something in between the plates of the capacitor that is not air, the capacitance is higher than the capacitance of the capacitor when there is only air. So why the capacitance of a capacitor increases if we remove the air in between the plates and we put instead another kind of insulator? Well, the reason is actually very simple. Let's draw here the plates of a capacitor and the insulator in between. When we polarize the capacitor this way, what happens is that in between the plates of the capacitor there will be an electric field which is oriented this way. The electric field will try to exercise a force on the molecules of which the insulator is made of. These molecules basically will stretch and will orient themselves in such a way that their negative side will be closer to the positive plate and the positive side will be closer to the negative plate. So it will be something like this: minus and plus, minus and plus, minus and plus, and again and again. You see that when we check at this point the voltage of the capacitor for a certain amount of charges, we will see that there are these internal charges of the insulator that are actually compensating the excess of charges on this side and the defective of charges on this side. The plus and minus will tend to neutralize themselves, and the plus and minus on these other sides will tend to neutralize itself. So what happens is that with the same amount of charges, the voltage at the end of the capacitor will be smaller than the voltage that it would be if there was no such a thing in between. So the voltage here in this equation, it's smaller when there is a dielectric in between the plates of the capacitor that is not air. If V is smaller, then C is greater. That's why the capacitance is higher when there is a dielectric in between the plates of a capacitor.